All right, hello everyone. Today we are doing some calculus 2, and we are asked to find the radius of convergence of the series starting from n equals 1 to infinity, n times x minus 4 to the nth power, all over 2 to the n. Now, when you're trying to find the radius of convergence, usually you're going to apply the ratio test or the root test. Today I'm going to be using the ratio test. Yeah, and I have written here, other tests may apply, such as the root test, geometric series, etc. It just depends what's given and what's the form. Okay. In this case, I'm going to use the ratio test, but just keep in mind that you can use other tests. Just look at the series that you have and take a look at it and see if it fits the hypothesis of each of these tests, and also if you'd get an easy answer after any computations here. All right, so applying the ratio test, I'm going to take the limit and call this limit L of an plus 1 over an. An here stands for n times x minus 4 to the nth over 2, and it's basically all the stuff that's next to the summation sense. And that's what an stands for. An plus 1 is the term after an. And essentially what that is you're replacing all the n's with n plus 1. Okay. And what we're going to do now is we're going to take this limit as n goes to infinity of this ratio of an plus 1 over an, which would equal, so we're going to do some writing here, and there we go. Be n plus 1 times x minus 4 to the n plus 1 all over 2 to the n plus 1. So that's that whole an plus 1 right here. That's what I just wrote down. And then divided by a sub n. A sub n is all the stuff up here. So we'll go ahead and divide that by n times x minus 4 to the n over 2 to the n. And we would get as follows. Now, you want to simplify this expression, and I see that I have what we call a complex fraction. It's one fraction within a fraction. So you got this big fraction divided by this one. And what I'm going to basically do is kind of simplify this by dividing. When we divide fractions, we invert and multiply, so that's what I'll just do right now. So times 2 to the n over n times x minus 4 to the n. And what we're going to do here is we're going to simplify a bit. And simplification basically means cancellation here. So for example, there's a 2 to the n here, there's a 2 to the n that can cancel. You'd have a 2 to the first left. You would have an x minus 4 to the n that can cancel there, and you would have an x minus 4 left to the first on the top, n plus 1 and n, and no n, and that n here do not cancel because n plus 1 and n are different terms, so they do not cancel. And I'm going to do as follows. I'm going to take the n's out of the absolute value, and that's legit because n is a positive integer. Okay. However, the x value, that can be positive or negative, so we're going to keep that inside the absolute value. And I'm actually going to do this as well. I'm going to factor the absolute value of x minus 4 because our limit is only interested in n. It's not interested in x's, so we can go ahead and pull that out. And if we take this limit here, it has the form of infinity over infinity. So if you want, you could apply L'Hopital's rule, but you can also look at this as two, using the same techniques you use maybe in like your first calculus class where you have one polynomial over another, and it's the leading terms are what's important. So the limit here would wind up being 1/2, okay? So I'll leave it at that. The limit would be 1/2. So this is our limit, but see, we are looking for values of x for which our series converges. Okay. And we're using the ratio test, and the ratio test tells you that your series will converge when your values are less than 1. So we're going to set that to be less than 1. So it all depends on the test that you're working with. I'm going to multiply both sides by 2 to end the fraction, and this right here would be your radius of convergence. When you're finding your radius of convergence, you're looking to look at a statement that looks something like what we just got right now. Once you get that isolated, your radius is that number, so it's 2. There are instances, so let me just write down there for our answer, r equals 2. There are instances, let me speak of when this limit up here will equal 0 and infinity. If the limit is equal to 0 of an plus 1 over an absolute value, the limit of that equals 0, then the radius of convergence is infinity. And if the limit is infinity, then the radius of convergence is 0. Okay, so you also have that at your disposal. So in our case, our radius is 2. Now the next question that might come up when doing these problems is finding in the interval convergence, and we'll do that in another video here. Okay, all right, thank you for your time.